Our next speaker is Stefan Bendig from Würth Elektronik Group. He's going to chat about the state-of-the-art of industrial stretchable PCBs and potential for future development. And while Stefan's on his way up, can I see if Luke and Christoph are here? Can you wave at me if you are? There's Luke. No Christoph here, I don't see. Okay. Christoph's last up, so that's not a problem. Thank you.
Perfect. So hello everyone, I'm Stefan Bendig from Würth Elektronik, and today I will talk about the state-of-the-art of the industrial stretchable PCBs and its potential for future development. So first, a small agenda for my talk is I will talk about the basics of the concept, then material properties, design basics, and then about 2 projects for the development, and then you get a short summary. So first of all, why should anyone use stretchable PCBs? I think you could, in the whole day, different applications for this, but of course the well-known applications are for the smart textiles. You could also see this in the room on the other side. Then for robotics, automotives, energy, sensors, and also for healthcare is it very important. And also it's a market with a big growing potential. You can see here 2 different applications. So one is textiles with LEDs in it, so you can use it for the modeling, but also, of course, for security and also sensors in it, and also a medical application. You can see here it's a belt for the treatment of newborns and premature babies, so that was then watching over their lung capacity and also for the heartbeat. So is the premature babies cure or do they have any health problems? So yes. And also, what are benefits from this part? Is of course, if you have a stretchable PCB, that can save you space. Of course, stretching, or if you have stretch it or not, so it will be smaller in the non-stretched status and then bigger in the stretched status, and you don't have to put in this PCB that is on the whole area. And of course, if you compare it with the normal rigid PCB, the big green PCB everyone knows from his PC, I think nobody wants this in his catheter, for example, or in his clothes. So because if you have a big board in it and moving, that would be, of course, a big problem. And also, for the production and also for the users in the applications, it will be much easier. And I think also you have the chance to see here different kinds for the stretchability, and normally there are 3 different parts to make it stretchable. The first one, I think over the half in the presentations here have the stretchable inks in it. So with normally a silver ink. Then also what we are using at Würth Elektronik are the main underlying structure, and then also possible is an alloy that also is stretchable. You can, for example, see this and talk with this from the Fraunhofer IZM. Yes. How do we make it stretchable? I said before, we are using a main underlying structure of copper, and we laminate copper on a TPU substrate. So of course TPU is stretchable, and then we have the meandered form copper on it for the stretchability, and then you can use it in our normal manufacturing source and don't have to change any part of our manufacturing. So also this enables a faster production than if we have to change everything. And of course, if the PCB is produced, you can use it for different applications and also use it in other parts and progress it even more. So for example, you can see it here with thermoforming, therefore it gets a little bit stability of polycarbonate, and also we can laminate it, for example, on textiles. So especially if it's TPU, you don't need, for example, a glue with it, so the TPU itself can be